shall we start the program, sir?
Yes, sir.
Yes, fine. I'm very happy to welcome you all for the fifth day of our faculty development program, Emerging Innovations in Chemistry and Chemical Technology. I welcome our resource person of today's session, Dr. P. Manikandan, Associate Professor, Department of Chemistry, Kongu Engineering College, Perandurai, to deliver the lecture on the title of Advanced Oxidation Process. I extend my welcome to all the faculty participants who are all supporting us continuously on the fifth day of this session via Google Meet and YouTube. Now I invite Mr. Steve Parimala, Assistant Professor, Department of Chemistry, to introduce our resource person.
Very good morning to all. It's my great honor to introduce the resource person of the day, Dr. P. Manikandan, Associate Professor, Department of Chemistry, Kongu Engineering College, Perundurai, Erode. Our resource person is having 25 years of teaching experience. He has published more than 14 research articles in national and international journals, and he has published 6 textbooks. He has submitted more number of projects proposal to various funding agencies such as DST, AICTE. He received research grants about 48.82 lakhs through various schemes. He has acted as resource person for about 4 invited lectures. It's our honor for having such a wonderful personality as a resource person in today FTP. Thank you for the opportunity given to me. Thank you.
Thank you, ma'am. We welcome our resource person to share his views on in today's title. Sir, welcome, sir.
Thank you, sir.
Thank you, sir.
Thank you, Parimala madam, for nice introduction. First of all, I would like to thank the management of Arasu Engineering College for giving me such an opportunity to act as a research person in this 6 days faculty development program on emerging innovation in chemistry and chemical technology.
Anirudh, sir, audio is not available. Yes.
Yes, sir. Is it okay, sir?
Fine.
Thank you. Thank you.
Yes.
Hello. Once again, I welcome you all for this session. Today's my topic is advanced oxidation process for hazardous textile dye degradation. I just, without wasting your time, I just started directly into the topic. We all, as a human being, we love.
Sorry, ஒரு ஆடியோ மெர்ஜ் ஆகுது சார். சிஸ்டம் ஆடியோ ஹெட்ஃபோன் ஆடியோ.
Sir, is it okay?
Yes, sir, there is some disturbance through the
Hello.
ஆடியோ எக்கோ இல்லை.
One second.
Somewhere it's low and we are mixing with some other.
Is it okay? Hello.
Yes, sir. Thank you.
Is this clear, sir?
Okay, sir. Thank you.
Thank you. As a human being, we all love to look at different colors. Without colors, we cannot imagine the life. But at the same time, there is a lot of problems that may be associated with such a colors and appearances. Here I take conservation in this topic as textile industries mainly because This textile industry is the second largest employment generating sector in India. That is, this decides the economy of the total country. And this is not a new technology. This is not a new technology for our India. Even from our Harappa civilization, just think about that. A long back, more than 4,000 years back, we started such a textile processing. And very really proud to say here, India is the second largest producer in fiber in the world. The major fiber produced is cotton materials. So we make the world in a different colors. It's a very simple technology. What we used in the previous years, first in general, it is a diaper preparation and preparing a yarn and removal of excess liquor after dyeing process and drying and yarn preparation and finally weaving. These are all the very oldest technology what we adopted for dyeing a fabrics. This is a modern technology what we are using for making wonderful different colors. You know very well that we all, when you are going for a purchase of any other materials in the shop, you just think about the different colors or shades in a different direction. So all these colors are made such a wonderful technologies. Initially, the cotton may be converted into the yarn may be sized, and it may be weaved, and a wet pre-treatment may be treated, and after that we are going for a dyeing and printing, then goods preparation. Finally, it comes to the retail stores and the consumers. With all such a wonderful makings, we got a wonderful, colorful fabrics. The fabrics may be of different types. The fabrics may be of different types. That may be cellulose fibers, protein fibers, synthetic fibers, etc. In these cellulose fibers that consist of cotton, rayon, linen, etc., and similarly protein fibers, wool, angora, mohair, and etc. Synthetic fibers, polyesters, nylon, and etc. So, in such a fabric materials, how I am going to make such a colors to these materials? So, necessary conditions to be a dye. A dye should be a dye. So, for such a case, all the colored substance cannot be called it as a dye. All the colored substance is not a dye. But dye is a colored substance. Dye may be of natural or synthetic coloring matter. That can be used for staining the materials, especially different types of fabrics what we discussed earlier, that is cotton or whatever. So this colored substance is termed as a dye if it fulfills the following conditions. That is, the dye should create a suitable color, whatever we require, and it should be fixed to the fabric, and it should not come out from the fabric while on washing. You know very well there are a lot of problems while on washing. The color may be drained and the color of the material may be drained. So the quality of dyeing, that may depends upon that how it is fixed on the fabric. Sometimes this fixer dye may be washed out by using alkali and washing sodas, alkalis such as washing sodas. Because the soap may be using an alkali nature, if it is washable, the color may be washable, it can be removed from the fabrics. And these dyes may be of a different form, that is while on visible, that is a physical form. This may be in a powder form, that may be a grain form, fine powder, micro, or a lump, or solution, or paste form. This is a physical nature. So depending upon the physical nature, we can classify it in such a case. And in the case of an application case, this can be divided into acid, basic, direct, and all these things are, very well about the insoluble dye, matte dye. And why this much of classification may be required means there are certain dyes that can be applied for different fabrics. Certain fabrics that can use only this particular kind of dyes. On considering the chemistries depending upon its structure, we can call the same dye into different names as nitroso dye, nitro dye, azo dye, stilbene, xanthine, quinine, thiazole, etc., and going on. These are all the different types of dye stuffs what we are utilizing depending upon the usage. The selection of dyes that may be vary from industry to industries, and similarly that can be varied depending upon the fiber what we are going to dye. For cellulosic fiber, we have to consider about what is cellulose. Cellulose is made up of repeating units of glucose units. Most commonly used dye for a cellulose is reactive dyes, and sometimes there can be direct dyes. Matte dyes are also used in alcohol dyes, and the structure of certain dyes is also be given here. The protein dyes, the protein fibers that can be using azo dyes, triaryl methane dye, anthraquinone dyes, and similarly certain synthetic fibers, you know very well about polyesters. So for such a dyes, we can use a monoazo dye, diazo dye, triazo dye. Depending upon the fiber, the usage of dye will also be. For the cellulose fiber, that is a cotton fiber, it chemically described as 1,4-BD hydroglucopyranose. Why I am detailing going into the structure of the cotton fiber means the degradation itself, this will be taking part, and this will create certain additional problems to the human and society also, environmental society also. The structure of this cotton fiber has a primary and secondary alcohol. Just look over here, my cursor. So CH2OH is a primary alcohol, and secondary alcohol is also be present in the polymeric set. That's why generally the cotton fibers are hydrophobic. It absorbs more and more quantity of water. Hydrophilic in nature, these cotton fibers are hydrophilic in nature. Because of this hydrophilicity, this absorb more quantity of water and swells. And generally, these cotton fibers are hydrolyzed by hot acid and concentrated alkalis. When the cotton is treated with the caustic, this will develop a silk luster and stops the longitudinal shrinkage, and this process is called it as mercerization. The mercerized cotton possesses increased moisture and dye absorption. So this will facilitate the dyeing of the fiber material, that is cellulose fabric material. Cotton may be chemically react with fiber reactive dyes in solution. When I am moving into cellulosic fiber to protein fiber, proteins that may be available from the animal hair, that is body of sheep. Silk is and another thing, silk is a lustrous tough elastic fiber produced from silkworms. You know very well about பட்டு சாரி அப்படின்னு நம்ம சொல்லிட்டு இருக்கிறோம், that is silkworms. Both these wool and silk fibers are protein substances with both acidic and basic properties, because the structure of this protein fiber that may contain amino acids, and it may be arranged in a polypeptide chain. The structure may be indicated in this slide. This silk like wool is a protein fiber that are nearly similar structure, and it comprises of 6 different amino acids, and Because of this presence of this amine and carboxylic acid, this will also be a hydrophilic in nature. This will also absorb water molecule. This can be dyed either with acid or basic dyes, and when it will be dyed with acid or basic dyes, it may form an ionic bonds. But at the same time, when it will be reacted with the reactive dye, this will forming a covalent bond. That is a very strong adherent bond may be formed when it will be dyed with the reactive dyes. Then coming into the synthetic fiber. Synthetic fibers, aminoacrylics, and this can be derived from an polymerization of acrylonitrile. And this polymer, a copolymer that will be with vinyl acetate and an acrylate or methacrylate esters. Polyesters may be formed by using such a polymerization process. And these acrylic fibers are hydrophobic in nature, and that is water resistant in nature. You know very well, most of the synthetic dyes are water resistant. And sometimes we are using a fabric with cotton blended synthetic fibers. And stability of this fiber, this synthetic fiber is also a little bit of higher when you are compared to the cotton and protein fibers. In these acrylics, there is no functional groups are present, and the fiber producers, they found some ways to modify this basic polymer by incorporating certain acidic groups to the polymer. The acidic group stands for sulfonic acid groups, like sulfonic acid groups. Upon drying and storing, it will retain sufficient acidic functional groups in the basic polymeric structure of these synthetic fibers. So, we discussed earlier different types of dyes and different types of fabrics. So these different types of fibers needs different classes of dyes for dyeing processes. Acrylic fibers are dyed with the basic dye. The nylon and protein fiber such as wool and silks are dyed with acidic dyes. Polyesters with the dispersed dye. Cotton maybe with vat dye. Modern synthetic reactive dyes and direct dyes. That says again different fibers that need different types of dyes. All these dyes that impart a very good color and make us very pleasant by its usage and in visually. But these dyes are so problematic in nature because of its chemical nature. Some of the good dyes what we prefer is also toxic to humans. No one knows about its risk to humans and the environment, because this will create, we thought that this particular dye is suitable for all these things, it will not create any, but after certain degradation, after certain partial treatment of such a dyes, that will create byproducts with a very harmful byproducts to the human and the environment. European Union particularly banned dangerous dyes formulated from such a toxic chemicals. Many modern synthetic dyes are very dangerous and carcinogenic in nature. I'll show you certain how these dyes are classified and prepared. A small video for you all.
audio is very low.
Dice are classified based on chemical present in the body, such as nitrogen, nitrosol dice, azo-dice, and bond N, and phenol dice, three double bond L. More classification of dice is a method of analyzing dice, one, such as acidic dice, basic dice, light dice, molding dice, and black dice. Uses of dice. These coloring substances are used in two types of plastic. These are used in textile, paper, leather, wood, and food industry. Example: polymer dye and molded and polymer fiber to form insoluble dye, polymer fiber. In food industry, natural dyes are generally used, but now federal agency has allowed the use of synthetic dyes, but within a permissible level. Variety of petroleum-based dyes, such as lubricant oils, waxes, gasoline, and polishes, use these coloring substances to color fur, hair, and other biological samples. You can use various types of coloring substances.
And all these dyes, all these different types of dyes, what we have used is not 100% transferred to the fabric. Only 15 to 20% of dye what we use is dyed on the fabric, and the remaining 80% is coming out as a wash. And there are certain industries, they are not taking care of such a wastage, such a dyes with the improper treatment and let it be into the river and whatever may be the water bodies. And show you another video, another pity video, what we are here.
மாவட்டத்தில் சாய ஆலைகளில் மாசு கட்டுப்பாட்டு துறையினர் அவ்வப்போது இணைந்து அகற்றினாலும் முழு அரசியல் செல்வாக்கை பயன்படுத்தி சிலர் சட்டவிரோதமாக சாய ஆலைகளை புதிதாக தொடங்கி நடத்தி வருவதாக அதிகாரிகள் தெரிவித்தனர். சாய கழிவுகளால் நிலத்தடி நீர் கெட்டு விவசாயம் சீர்கெட்டுள்ள இந்த நிலையில் நீரையும் நிலத்தையும் மாசுபடுத்தும் சாய பட்டறைகளில் தங்கள் பகுதிகளில் இருந்து அகற்ற வேண்டும் என்பதே அப்பகுதி மக்களின் வேண்டுகோளாக உள்ளது. பாலிமர் செய்திகளுக்காக
Is it okay, sir? Is it audible, sir?
Yes, sir.
Okay, thank you. This is what a small video clipping, how the general publics, because they may not aware of what is the chemistry or what is the problems that was associated when we laid out all these wastages. That is especially while on the last video what we are seeing is that a common public, they want only earning your money. They concentrate only on earning the money by simply using dyeing of certain fabrics in their own house itself. But these dyes, how it will be complicated and how it is going to be disturb our regular ecosystem is discussed in the later slides. Because we have to know about, we are in the position, we are as a teacher, otherwise we are all an educated people, so we all have take a decisions to create an awareness to the public, especially how these dangerous, maybe we can call it as a time bombs itself, with the silent time bomb, because this is a very silent, when it will be enter into the social environment, we may not know that how it is going to explode it, but this explosion may be very dangerous. This may affect not directly affect our human health, but at the same time it will affect our future environment. You just think over here, all these things are our responsibility to make aware of our publics to protect the environment. So you just listen, just please consider whatever may be the following slides, how it will be harmful to the society. Under certain conditions, these azo groups, that is while on treatment of these such a wastages, we just bring back the cracking of the higher molecules into the smaller molecules. And these may sometimes enter into our digestive tracts and some organs of the animals as well as including human beings. That will be affected. Nearly 24 aromatic amines are confirmed and it is implicated to be a carcinogenic to human beings. And 5% of azo dyes can cleave after the partial treatments. That will be dangerous to the human and the environment. Certain, there is acid orange 7 dye and food yellow dye. This is what the structure of acid orange 7 and food yellow, and both are differ only in the sulfonated functional group that may be present in the food yellow. Suppose when I am going for certain treatment, generally these azo groups may be cleaved and there will be a partial degradation maybe takes place and it will be converted into a different byproducts. Whenever these two dyes are degraded and partial degradation, if suppose it will be takes place because of the sunlight and because of some other enzymatic actions, when it will be converted into, you see here, the azo-bond degradation, this toxicity of the food yellow is slightly decreased, but at the same time, when you partially degrade this acid iron 7, that will nearly 100 times maybe increase its toxicity. This increase in toxicity is mainly due to the presence of this sulfonated group. Say for example, standard 1 amino, see here the structure of 1 amino 2 naphthalene and 1 amino 2 naphthalene with 6 sulfonate is here. The toxicity of sulfonilic acid This I said again, acid orange 7 is increased toxicity mainly because of the presence of the liberation of one amino 2 naphthol. And again, when you are comparing the toxicity of these two compounds, the toxicity of this particular compound without sulfonated functional groups is very, very, very higher. And similarly, the same thing. See here, the only a small difference we can observe here, this is 1 naphthalene sulfonic acid and 2 naphthalene sulfonic acid. But the toxicity of these 2 naphthalene sulfonic acid is very severe compared to this 1 naphthalene sulfonic acid. And general public, I said initially, the general public, they may not know about what is its structure that may be present behind these dyes. They simply think of that this is an orange color, this is a pink color, this is a green color, that's all. They may not aware of whatever may be the toxicity. And one more very important thing, this is a benzidine ring is also be present. This is highly, very potentially dangerous to environment. And European Union restricted these following amines, nearly 24 aromatic amines. Totally, worldwide it was banned. See here, this benzidine, otherwise this 2-naphthylamine or this 4-amino diphenyl, this elevates the bladder cancer whenever it will be entered into our human body. And again, there is a German dye plant. Total workers, 100% of the workers involved in distilling this 2-naphthylamine, all are suffered by bladder cancer. This 1,4 diaminobenzene is an aromatic amine whose parent azodide causes skin irritation, then chemosis, permanent blindness, acute tubular neurosis serving, vomiting gastrics, hypertension, and etc. Not only particularly these particular dyes and some of the additional chemicals what we are used for dyeing will also creating a problems. So you know very well a dioxin is a carcinogen and possibly this will disturb the hormone disturb. And toxic heavy metals like chromium, copper, zinc, all these things are known to be a carcinogen. Formaldehyde is also considered as a suspected carcinogens. So all of this particularly challenging the pupils with chemical sensitivities. That's all. Up to this slide, what we discussed about what are all the different dyes, how it can be classified, where I can use a different fibers and with the fiberic nature, and what are all the problems. And here I want to underline a word problem statement as these dyes, and especially not only these dyes, the partial degradation of these dyes is harmful to the environment. There are different treatment methodologies already available right now. That is chemical coagulation, adsorption process, reverse osmosis process, and biological treatment process. In the case of chemical coagulation, there are a lot of sludges may be developed. In the adsorption, all these harmful products that was adsorbed only on the topmost layer of the adsorbent. We still didn't give any other proper solution for the removal of such a dye. Still that may be available in the environment itself. Maybe all these things are tied in one such a way and stored in a particular environment. And there are industrial treatment, maybe maybe effluent treatment plant, there are solar ponds. All these things are converting such a harmful material into another kind, but that will not provide you 100% solution for such a problems. That's why I said again, all these treatment processes, it really gives a solution to our problems. The word is no. This will not give a proper solution. All these treatment methods are having certain advantages and disadvantages too. Say for example, coagulation is economically good. Activated carbon is remove a wide variety of dyes. And ion exchange method, it is without the loss of any adsorbent, that is we can economically use. Then advanced oxidation process, highly reactive free radicals are present in this advanced oxidation process. Compared to all other processes, it will be good. And the electrochemical process, it will create a huge volume of sludges and high cost of electricity too. Ozonation, a good decoloration may be occurred, but at the same time, ozonation, I said initially, it is a partial degradation of dyes, and there is no reduction of chemical oxygen demand, the COD. And there are a lot of disadvantages to this method also. But actually, what the really industries are like? Industries are looking for a very simple technology and advanced one. Technically, it should be an advanced one, and it should be a cost effective. Then only all the industries, they can avail such a treatment process. And it should be a maintenance-free technology for the treatment of such a textile wastewaters. Ion exchange process, electrocoagulation process, membrane treatment process, all this individually is not an economical one. But when you are combining all these technologies, the synergism of combining these technologies may be very helpful. Among these different technologies, now I am going to suggest a small technology as an advanced oxidation process, because in this process only we can achieve 100% mineralization, otherwise degradation of dyes, that is without any other by harmful byproducts formation. This advanced oxidation process, just I'm coming into this advanced oxidation process, what it implies. There are different types of methodologies. Say for example, Fenton's process. The Fenton's process may be of two types: homogeneous Fenton, heterogeneous Fenton, then photofenton, then photocatalysis, ozonation. All these things are an advanced oxidation process. All these things are advanced oxidation process. All this process, what it will create means, all which it is depends on means, there is a generation of hydroxyl radicals. Maybe the hero of the presentation, today's presentation, is these hydroxyl radicals. This will oxidize such a harmful byproducts into a simpler one. Why we say hydroxyl radical means this is a powerful oxidant, but at the same time it is a very short lived. That's why we know very well, we can say that it is hydroxyl radicals. Within this short lived period, it will create a much impact on such a harmful dyes. At the same time, it produces a harmless byproducts, and rate of the reaction can be controlled, and at the same time it is a highly reactive in nature. And this will not be a selective one. This can be easily generated. All these characterization make us to move on to this advanced oxidation process. The catalysis, that is photocatalysis, electrochemical process, Fenton reagents, then ionizing radiation, microwave, photofentons, photocatalysis, pulsed plasmas, ultrasound, UV, H2O2, UV ultraviolet radiation along with the hydrogen peroxide, and the synergism of combining hydrogen peroxide with ozone, then vacuum UV and wet air oxidation, all these technologies. And again, the star, a single star that indicates it's in a commercial application that can be used in a commercial application too. And there are double star that is used at the full scale right now in industries. I said it's an oxidation process. What this oxidation actually does? Generally, you know very well, there is a removal of electrons, the loss of electrons, that will be an oxidation. And here, the combination of this organic compounds that can be reduced into carbon dioxide itself, it's a degradation, it is oxidation process. And here, the free radicals formation, that is advanced oxidation process, that is free radical generation, particularly hydroxy radical. Why particularly hydroxy radicals means? The oxidation potential is 2.80 for these hydroxy radicals compared to all other species, chlorine, hypochlorous acid, hypoborous acid, permanganate, hydrogen peroxide, ozone. For all, when you are comparing all these things, this hydroxy radical is having 2.80 voltage of oxidation potential. It is more enough to oxidize whatever may be the complicated molecules that may be present. The rate constant for degrading these molecules, benzene, toluene, and everything that will be listed when you are comparing to the ozone is here. Such a high rate constant that may be present in the hydroxy radicals. Within a shorter period, that can decompose the very complicated, complex molecules. The free radical is not an ionic species. The equal cleavage of two atoms, say for example hydrogen peroxide, that can be cleaved into two hydroxy radicals molecules. These hydroxy radicals, maybe it is a reversible equilibrium process too. These two are combined and back to hydrogen peroxide formation will also be happening. The dot radical that indicates the radical center. These free radicals may be favored by photolysis, ozonation, by the addition of hydrogen peroxide, some heating, that is pyrolysis, and waves, ultrasounds, sonolysis. That will facilitates the formation of more and more free radicals. Once this will be initiated, a series of simple processes that will be carried over to reduce the complexity. The rate of this oxidation process, that is this generation of hydroxy radicals, that maybe depends upon the concentration of initiating species like hydrogen peroxide, pH of the solution, the pollutant concentration, temperature, ions, and some of the radical scavengers. So these are all the different methodologies that can be available for the generation of hydroxy radical. Non-thermal plasma, ozone and ultraviolet radiations, hydrogen peroxide with ozone. This is a synergism of combining two different technologies in a single reaction. Hydrogen peroxide with UV, hydrogen peroxide, ozone with UV, then by using a photocatalytic reductions, titanium oxide is a photocatalyst, electrohydraulic cavitation and sonolysis, supercritical water oxidation and gamma radiations. The areas for the opportunities for this advanced oxidation process: groundwater, water and VOC, volatile organic compounds, surface water, swimming pool treatments, water recycling, disinfection, industrial wastewater, and etc. These are all some of the contaminants that may be present in the wastewater successfully treated by this advanced oxidation process. That is amino acids, antibiotics, arsenic, chromium, coliforms, disinfection byproducts, drugs, residues, etc. how these hydroxy radicals are generated. This is a very small technical outline. The main objective of advanced oxidation process is to creating a hydroxy radicals. By photo-assisted ozonation, in the presence of UV radiation, when I am passing ozone into the water, this will produce a hydrogen peroxide, and this hydrogen peroxide on cleavage by using the photolytic cleavage, and this is creating a hydroxy radicals. And some other photocatalytic too. So by using a photocatalyst, that is titanium oxide, that absorb the UV radiation, and that will also creating a hydroxy radicals. Then ozone assisted with electrochemical without a photocatalytic activity. Ozone with hydrogen, that will create a hydroxy radicals. Especially for combining these techniques is mainly due to a synergistic effect of all these processes. All these processes that will create mainly hydroxy radicals. Sometimes there will be a chloride radical, and this effluent solution may contain a cocktail of this, creating a cocktail of oxidants. This cocktail of oxidant that attacks the non-degradable or highly complex organic, inorganic, hydrophilic, hydrophobic pollutants into a simpler one. In most of the cases, the UV, that is electromagnetic radiations, the wavelength from 4 to 400 nanometer, that can be applied to create such a hydroxy radicals. Generally, this advanced oxidation process that concentrate on 253.7 nanometer, where both the pollutant as well as the water that absorb these radiations. And this is for a quantum, this is for a calculation purpose. It's a quantum yield. Finally, we can go for a calculation of how economically we can treat this advanced oxidation process for the wastewater. This will give you a value of quantum yield, and the electrical energy used for UV radiations and hydroxy radical productions. In the case of batch absorption as well as in the continuous modes, by using this formula, whenever maybe the photocatalytic cleavage of hydrogen peroxide, that will create a hydroxy radical. These hydroxy radicals attacks the organic molecule and decompose or fragmenting these molecules, fragmenting these complex dye molecules into a simpler one. And the oxidation rate, this oxidation rate of the decomposition of such a dyes depends upon the concentration of the targeted pollutant. Because if the concentration is more, the concentration of the pollutant is more, the penetration of the UV light, into the water body is very less, and hence the production of hydrogen peroxide itself is decreased. The production of free radicals generated is less when you are moving into the highly concentrated and targeted pollutant. And similarly, whenever maybe the free radicals, hydroxy radicals are higher, there may be a higher treatment efficiency may be achieved. And similarly, higher the oxygen concentration in the surrounding that facilitates. So all this advanced oxidation process is focused on generating the radical molecules to attack the organic molecules. This is studies what we have done and published in an Iranian Journal of Chemistry and Chemical Engineering. It's a small comparison of 3 different dyes. Reactive blue dye. This is what an experimentation done in our laboratory itself, and what we have done in our environmental science Center for Environmental Research in our research laboratory of Kumbakonam Engineering College. CI reactive blue 194 dye, and direct red 7, and acid violet 17. This acid violet 17 is a triaryl methane dye. These two remaining 2 dyes are a diazo dye and at the same time benzene dyes. This is what the photoreactor is used in our laboratory itself for studying these purposes. This is what a reaction chamber, and this is it's an UV source. Large, there is initial concentration of the dye. We have studied from 100 ppm to 1000 ppm, that is different concentration of these three dyes are taken and studied for this photolytic cleavage, that is photo degradation, that is advanced oxidation process. Large degree of color removal efficiency, see here nearly more than near to 100%, near to large degree of degradation of all these dyes are taking place in the lower concentration, that is 100 to 300 ppm. This is mainly due to the formation of more and more number of hydroxy radical generation in the lower concentration, mainly because of at lower concentration there is a lot of possibility for the penetration of such a UV light into the dye molecules, and there is a more and more quantity of hydroxy radicals are generated. Whenever the concentration maybe increases, this degradation efficiency decreases, mainly because of the disturbance of this higher concentration to the penetration of this UV radiation and the decrease of the formation of hydroxy radicals. This will also an evidence for the generation of hydroxy radicals. Wherever there may be a more number of hydroxy radicals, there is a higher efficiency. Wherever maybe there is a lesser, then automatically there is higher the concentration, the hydroxy radical formation itself is very less, and the degradation efficiency is very less. Nearly we have achieved 98.18% within 10 minutes of time, that is for RB dye, that is reactive blue dye. But for the remaining dyes, nearly 35 minutes for acid violet and 20 minutes for direct red. This increase in dye concentration that induces the internal optical density, and the solution becomes highly impermeable to UV radiation, and this may lead to decrease in the production of hydroxy radical and hence the removal efficiency. And the pH plays an important role in the degradation studies. You see here, this is the initial pH what we have taken. This is the final pH after the degradation process is over. The initial pH of the dye solution from 3 to 10, that initial pH is decreased. This is mainly because of during the reaction phase there is an acidic byproducts are formed. During the degradation there is an acidic byproducts are formed, and hence there is a decrease in the pH, final pH was observed. This says that there is a mineralization process is taking place during the photocatalysis, that is advanced oxidation process is taking place. This drop in the solution pH is mainly due to the formation of an organic acid, as well as some of the inorganic acids may be formed as a byproduct. Upon increasing the initial pH, that is from 10 to 12, there is no remarkable changes in the final pH. Again, the same initial pH is going on. The degradation efficiency with the initial pH, At the lower pH, all the three dyes shows a higher removal efficiency. At the pH 9, that is 99.64% of removal efficiency was achieved at the pH 9. Decreased trend is observed in the decolorization efficiency with an increase in the pH from 9 to 12. That is, this increase in pH will not favor the formation of hydroxy radical in this case. the decolorization efficiency is faster in the RB solution, RB, that is reactive blue, compared to the remaining one, that is at a higher pH, mainly due to the deactivation of hydroxy radical, is more predominant than the degradation process. That is, the reaction of hydroxy radical with HO2 minus is approximately 100 times faster than the reaction of hydrogen peroxide. That's why there is a decrease in efficiency is found on higher the initial pH. Whenever maybe we are increasing that is, we thought that we know very well, whenever maybe there is a more number of hydroxy radicals, so the efficiency is higher. So why not we can increase the initial oxidant concentration, so as to favor more number of hydroxy radicals. So in such a case, when I'm increasing the initial concentration of the oxidant, the removal efficiency increases, but only up to 50 millimoles. 50 millimole of initial oxidation concentration. Then after that, the decolorization efficiency is decreased. This is mainly because of, after the initial dosage of 60 to 100 millimoles, the destruction of these hydroxy radicals, by the hydrogen peroxide itself is happening, and there is a formation of HO2 radicals. These HO2 radicals absorb more and more quantity of hydroxy radical, and hence the number of hydroxy radical formation is decreases, and optimum initial oxidant concentration favors the formation of more and more hydroxy radicals. The possible degradation mechanism for reactive blue dye is represented over here. Initially this oxidant molecule attacks this particular N bond, and this will be converted into a sulfonated groups here, and the bulkier group formed here, this bulkier groups separated. This is what a mineralization process was initiated. Initial mineralization process that will create such a byproducts. Further, the generation of this hydroxy radical further attacks the molecule, and it will be splitted into a non-harmful byproducts like a carbon dioxide. Splitter, that is, the demineralization process is continued, and 100% mineralization is achieved during this advanced oxidation process, and it will create a harmless byproducts of carbon dioxide. This is a possible degradation mechanism of direct red dye, and this will also creating a harmless byproducts at the final. This is a degradation mechanism for acid violet, but when you are comparing these three dyes, RB194, it gets easily degraded compared to AB17. This is due to the increased complexity of the dyes. This is a very small cost analysis comparing the cost of the chemicals we are utilized per meter cube, that is 1000 liters of the dye solution, and the energy consumption, that is the energy utilized for the UV light for 1000 liters of wastewater solution, and it will be calculated for the consumption in terms of US dollars and cost of energy, and combining these two things, finally, hello?
Nothing, sir. You can do, please.
Okay, sir. Thank you. The total cost for 1.04 US dollars per meter cube, that is nothing but is nearly 70 to 80 rupees per meter cube of the solution. for young researchers, suppose if anybody is interested to doing in future small recommendations for future studies are given over here. The same thing, the same process, the hydroxy radical generation, comparing this with an electro-oxidation process. This photo-oxidation can be compared with the electro-oxidation process, or combining this electro-oxidation with the photo-oxidation on different dyes, different complexity can be studied as a comparative study, or creating a different catalyst or different photophenton process combination for industrial applications, or instead of going for such a synthetic way, we can directly going for an industrial effluent, combining synergization of all these process. And I think so I have given good information for you people. Thank you for patient listening. If you have any queries, you please ask me, and I will be here for answer whatever may be your questions. Thank you, sir. Thank you, sir. Thank you very much, sir.
Sir, thank you very much, sir. Thank you.
Thank you, sir.
Thank you, Professor Dr. P. Manigandan, for his deep view on the advanced oxidation process of various dyes. Now the session is open to discuss with our resource person. Participants can raise your doubts and then discuss with our resource person. The session is open for you. Okay, I think there is no questions. Okay, just a minute. Sir. Somebody is typing in this chat box over there. Thank you. Yes. Then now I invite Dr. M. Vetri Selvan, Assistant Professor, Department of Chemistry, Arasu Engineering College, to share our gratitude as a vote of thanks.
A very good afternoon to all. It gives me great pleasure for proposing vote of thanks for the FTP on the title of Advanced Oxidation Process for Hazardous Textile Dye Degradation. I render my heartfelt thanks on behalf of our management and our department to our research person for sharing his insights on advanced oxidation process with us. I hope all the participants had a great and informative session. Thank you all.
Thank you, sir. I wish to thank myself once again, our resource person, and all the participants for attending the session. Thank you once again. Thank you once again. Thank you, one and all. Now
Thank you, sir.
feedback-
Thank you.
Thank you, sir. Thank you very much. Feedback.
Thank you, sir.
Sir, please.
Thank you, sir. Thank you for all the participants for patient listening. If you have any, feel free to ask me. Maybe I am very much of thankful to the management and the Arasu Engineering College professors and everyone. Thank you, one and all.
Sir, thank you very much. The feedback link will be shared now in the chat boxes in Google Meet and YouTube also. Thank you.